Hey everyone, welcome back to Tech Career Deep Dives.
Today we're tackling a topic that sounds like science fiction, but it's quickly becoming reality.
What if I told you that by 2026, a significant chunk of mid-level engineering management might not be human anymore?
Yeah, we're talking about how intelligent multi-agent systems are stepping into those roles, and it's happening faster than many realize.
It's a huge shift, impacting careers, company structures, and the very nature of team leadership in tech.
Absolutely. This isn't just about automation, it's about distributed AI systems taking on complex, collaborative tasks.
So, today, we're going to break down what these systems are, why they're so disruptive, and what it means for your career.
We'll dive into real-world examples, explore how companies are actually implementing this, and look at the skills you'll need to thrive in this evolving landscape.
Get ready, because the future of engineering management is already here.
Let's dig in.
Alright, Sam, let's start with the basics. When we say intelligent multi-agent systems, what exactly are we talking about?
Great question, Alex. It's not just one big AI doing everything. Imagine a team of specialized eyes, each with its own specific task or goal. They communicate, negotiate, and collaborate with each other to achieve a larger objective. Think of it like a highly coordinated digital orchestra.
So, instead of a single conductor, you have multiple intelligent instruments, each playing its part and adapting to the others in real time?
Exactly. Each agent has a degree of autonomy. They perceive their environment, make decisions, and act, all while interacting with other agents. This collective intelligence allows them to tackle problems far too complex for a single AI or even a single human manager.
That makes sense. So, how does this translate into replacing mid-level engineering management roles specifically?
Well, many mid-level management tasks are inherently repetitive, data-driven, and involve coordination. Things like task allocation, progress tracking, resource optimization, even some conflict resolution within processes.
And these are areas where MOS can really shine, right? They can analyze vast amounts of data without human bias.
Precisely. They work 24/7, across time zones, ensuring consistent project oversight. They can identify bottlenecks, reassign tasks, and optimize workflows in ways a human simply can't, or at least not at that scale and speed.
It sounds like a significant leap in efficiency and objectivity. But why is this becoming so critical now, by 2026?
Several factors are converging. The rise of sophisticated AI models, the increasing complexity of software projects, and the permanent shift to remote and distributed teams. MOS are perfectly suited for managing highly distributed workforces, bridging communication gaps, and maintaining project momentum without constant human intervention.
Plus, the sheer volume of data generated in modern engineering projects must be overwhelming for human managers to process effectively.
Absolutely. MOS can process and act on that data in real time, making micro-adjustments to keep projects on track. This translates directly into cost savings and faster delivery times for companies.
I can imagine there are some common misconceptions floating around about this. What's the biggest one you hear?
The biggest misconception is often the Skynet taking over fear, or that it means all management roles are disappearing. That's simply not true. MOS aren't replacing senior leadership, strategic visionaries, or roles focused on complex human issues like team morale, mentorship, or ethical dilemmas.
So, it's more about augmenting and then replacing specific, quantifiable tiers of management, rather than a wholesale takeover?
Exactly. Think about those project lead roles that mostly involve shuffling Jira tickets, running stand-ups, and ensuring process adherence. Those are ripe for MOS. Human managers can then elevate to more strategic, empathetic, and innovative roles.
It's a shift in what value a human manager provides, moving away from the purely administrative. Let's get into some practical applications now. Where are we seeing these systems in action today?
We're seeing them emerge across the board. In software development, for example, MOS can literally manage sprint backlogs. Imagine one agent analyzing project requirements, another assigning tasks to developers based on their skills, availability, and even their past performance data. A third agent might be optimizing the CI/CD pipeline to ensure smooth deployments.
So, it's not just assigning tasks, but actively optimizing the entire development lifecycle?
Precisely. Another great example is in infrastructure management. Think about cloud platforms like AWS, Azure, or GCP. MOS can monitor resources in real time. They can automatically scale services up or down based on demand, predict potential outages before they happen, and even optimize cloud spend by identifying inefficiencies. You might have agents specialized in security, cost, and performance working together.
That's huge for companies dealing with massive, dynamic cloud infrastructures. Any other industries?
Definitely. Supply chain logistics is another big one. MOS can optimize delivery routes, manage inventory across multiple warehouses, and predict demand fluctuations with incredible accuracy. They can coordinate with dozens of suppliers and distributors simultaneously, minimizing delays and waste. For instance, a major e-commerce company might use MOS to manage its entire delivery network, from warehouse picking to last-mile delivery.
These examples really highlight the collaborative nature of these systems. For companies looking to adopt this, what's a good step-by-step approach?
It starts with identifying repetitive, data-driven management tasks within their current operations. Don't try to automate everything at once. Then, pilot an MAS in a small, low-risk project. Something contained where you can monitor performance and gather data without disrupting core operations.
So, start small, learn, and iterate. What about integration with existing tools?
Crucial. The MOS needs to integrate seamlessly with tools like Jira, GitHub, Slack, and your existing CI/CD pipelines. It shouldn't be a siloed system. Finally, scale gradually. Monitor performance closely, gather feedback from human teams, and continually refine the agent's objectives and communication protocols.
That sounds like a sensible, iterative approach. What kind of tools and resources are available for someone looking to get into this or for companies looking to implement it?
There are some fantastic frameworks emerging. OpenAI's Assistance API is a powerful starting point, allowing you to build agents with specific instructions and tools. Then you have open-source frameworks like LangChain and Microsoft's AutoGen, which are designed specifically for orchestrating multiple AI agents to work together. And CrewAI is another popular one for building collaborative AI crews.
These frameworks provide the scaffolding, then. What about the underlying infrastructure?
That's where cloud platforms come in. AWS SageMaker, Azure AI, and Google Cloud's Vertex AI all offer robust services for training, deploying, and managing AI models, which are the brains behind these agents. These platforms also provide the necessary compute power and data storage for MOS to operate at scale. Understanding them is key.
So, it's a combination of specialized frameworks and powerful cloud infrastructure. Moving on to advanced insights, how do these systems tie into broader industry trends?
Well, one major trend is how AI and automation are fundamentally changing traditional developer roles. With MOS handling project management, developers are freed from a lot of administrative overhead. They can focus more on complex problem solving, innovation, and designing the systems that these agents will operate within. The nature of coding itself is shifting.
It's not just about writing code, but about designing intelligent systems. Another big trend is the permanence of remote work for many tech companies.
Exactly. MOS excel in distributed environments. They can bridge communication gaps, ensure consistent project oversight across different time zones, and maintain project momentum without constant human intervention. They provide a consistent, always-on manager that doesn't suffer from fatigue or time zone differences.
That's a powerful advantage for global teams. And what about the increasing value of full-stack roles over specialized ones?
Mid-level managers often act as bridges between different specializations: front-end, back-end, QA, DevOps. MOS can now perform much of that cross-functional coordination. This means human engineers need to be broader, more adaptable, and possess a deeper understanding of system-level thinking. The full-stack mindset becomes even more critical.
So, the human role shifts to higher-level strategic thinking and system design, rather than just managing specific components. What other trends do you see on the horizon for MOS in management?
I think we'll see hyper-personalization of project management. MOS will adapt to individual team members' working styles, strengths, and even their preferred communication methods. This could lead to incredibly efficient and tailored workflows for each developer, maximizing their productivity and satisfaction.
That's fascinating. A manager that truly understands and adapts to each team member. What about predictive capabilities?
Oh, absolutely. Predictive management will become standard. MOS will be able to foresee roadblocks, identify potential skill gaps, and even predict budget overruns before they become critical problems. They'll proactively suggest solutions or reallocate resources, turning reactive management into truly predictive oversight.
That's a game changer for project risk management. But with such powerful systems, we have to talk about the ethical implications.
Definitely. Ensuring fairness, transparency, and accountability in MOS decisions is paramount. We need to build these systems with explainability in mind, so we understand why an agent made a particular decision. And we need human oversight to step in for ethical dilemmas or situations where a purely data-driven decision might lead to unintended negative consequences.
So, for professionals listening, what are the next steps they should take to prepare for this shift?
First, deepen your system design and architecture knowledge. Understanding how these MOS integrate, how to design robust, scalable systems for them, will be invaluable. This isn't just about building a feature. It's about designing the ecosystem where intelligent agents thrive.
And those cloud platforms you mentioned earlier?
Absolutely critical. MOS often live and operate entirely within cloud environments. So, mastering AWS, Azure, or GCP is no longer optional. It's foundational for working with these systems. Focus on their AI, ML services, their orchestration tools, and their security features.
Finally, the human element. If ICE are handling the data-driven tasks, what skills become even more important for us?
Soft skills and communication become more critical, not less. Strategic vision, empathy, coaching, conflict resolution for truly human issues, and the ability to manage the MOS itself. It's about leading people and guiding intelligent systems, rather than simply managing tasks. Your ability to connect and inspire will set you apart.
It sounds like a fascinating, challenging, but ultimately exciting future for engineering professionals.
So, to recap, intelligent multi-agent systems aren't a distant future. They're already reshaping mid-level engineering management, and rapidly accelerating towards 2026.
They offer unparalleled efficiency, scalability, and objectivity, taking over repetitive, data-heavy tasks. This frees human managers for more strategic and empathetic roles.
We discussed how these systems are impacting software development, cloud infrastructure, and supply chains, driven by trends like remote work and the evolution of developer roles.
The key takeaway is that the nature of work is changing, and those who adapt will thrive. It's about working with *AI, not being replaced by it.
For your actionable next steps, first, start diving into MOS frameworks like Autogen, CrewAI, or LangChain. Experiment with them.
Second, seriously deepen your cloud architecture and system design skills. These are the foundations upon which MOS are built and managed.
And third, hone your uniquely human skills: leadership, empathy, strategic thinking, and complex problem solving. These will be your superpowers.
The future is here, and it's intelligent, collaborative, and requires us to evolve. Thanks for joining us for this deep dive.
If you found this insightful, please like, subscribe, and hit that notification bell. Let us know your thoughts on MOS in the comments below.
We love hearing from you. Until next time, keep learning and keep innovating.